Welcome back to Algebra 1, Chapter 12, Section 4 in this book. We're talking about completing the square, and I even drew a rectangle, not a square. You have to imagine. Anyway, this is another little tool to go in your toolbox for solving quadratic equations. You've learned how to factor them. You learned the quadratic equation, the thing with the b and all that. You know you can solve it by graphing. You can solve it with your calculator by graphing, or by using the second trace feature and getting the zeros. You can solve it by programs. Remember quadratic equation, discrimi, a quad, b quad, all of these are programs, ways you can solve it. Well, here's one more, and you're thinking, I don't need another one, but this one's good too. When you when's the time to use this is when you have an equation that cannot be factored. Some of them can't. Some of them you can't think of anything that you multiply to get the c term that added or subtracted is the b term. Now, it drives me crazy about your book is they will pick ones that you can think of something for, and then they do completing the square. And really, if you can factor it, that's usually easier. So we'll just pretend like they can't be factored. But that's when you use it, when you can't factor. Okay, so how do you do it? First of all, you take your c term and move it to the other side by doing the opposite. What's the opposite of minus 24 plus 24? What you do to one side, you do the other one. That one cancels out and it goes over here. You leave a blank here. Now, I'm not real big on what the blank is for, and I usually skip it because you never use it for anything. I'll explain to you what I mean. Okay, so how you do it is you take the b term, this one with an x, and you cut it in half. But first you write parentheses and you put an x right here. Okay, so step 1, put parentheses and an x. Step 2, take this one that's got an x and cut it in half. So half of 10 is 5, and it's plus 10, so it's plus 5, and you write it there and you put a square right there. Then you take this 5 that you just wrote here and you square it and you add it over here. Now technically you're supposed to add it here too, because the only reason why we're allowed to do this is you can do anything you want in math as long as you do it to both sides of the equal, and what we want to do is add 25 over here, so we write one over here too. But you will never do anything else with that 25, and if you forget to write it there, you'll still get the right answer. So sometimes I just don't write it. Okay, because this is what I do. See how this is a triangle? So it's the completing the square triangle. Okay, math jokes are few and far between, so you need to laugh at that. We're doing the completing the square triangle. Alright, see, so you first write your parentheses, second write your x, third cut this in half, then square it and write it over here. And there's our triangle right there. Whoop, whoop, whoop. Okay, so now we do this. 24 plus 25 is 49. And now we're just solving for x. Y is x down low, it's got plus 5s squared. We want to work from the outside in. The opposite of squared is square rooted. What you do to one side, you do to the other. So that frees it. It's x plus 5 equals. Now remember how sometimes they want you to write plus or minus and other times they don't? Now they do. So write plus or minus 7. Because the square root of 49, 49 is 7 times 7. One gets dissolved in acid, the other one gets out. Okay? So now, y is x on line scale plus 5, we do minus 5, and what we do to one side, we do to the other. So we end up with x equals negative 5 plus 7 and negative 5 minus 7. Because remember, this is a parabola and it crosses in two places. So we need both answers, all right? So now, negative 5 plus 7 is 2, and negative 5 minus 7 is negative 12. So this point right here is 2, that point is negative 12 that my parabola crosses. And those are my two answers. Ta-da! Not terrible, right? So let's do this one, okay? So first we write, now this one is terrible, I mean it's like a crazy hard one. I don't even expect you to be able to do that one. I expect you to be able to do this one. This one I want you to understand me doing it because it's in the book and I don't want you to get freaked out by winning your book. Okay, so First, we move the 3 over here because it's the opposite, so it's plus 3. We leave a space right there. We draw parentheses and we put our x here. Now we cut this term in half. This term is an understood negative 1. What's half of understood negative 1? Negative 1/2. And it's stood, not understood. Okay? Then we square it. Negative 1/2 times negative 1/2 is positive 1/4, because 1 times 1 is 1 and 2 times 2 is 4, and 2 negatives make a positive. And we write it over here. Technically, we're supposed to write it there too, but I usually forget and don't do it. Don't tell on me. Alright, so now we do this. 3 plus a fourth is 3 1/4, but remember, we prefer improper fractions in algebra, so that's 13/4. Now, why is x not alone? It has a negative 1/2 and a squared. We're going to get rid of the squared first by square rooting both sides. That frees it from the radical. X minus 1/2 equals plus or minus the square root of 13, and then the square root of 4 is 2. So it got out too, because remember, 4 is made out of 2 times 2. One gets dissolved, the other one gets out. It's right there. Now we've got to get x alone and do the opposite of minus 1/2 plus 1/2 to both sides. So we end up with, excuse me, 1/2 plus or minus the square root of 13 over 2. But because these have the same denominator, we can actually put them together and say it equals 1 plus or minus the square root of 13 over 2. Now that is really an Algebra 2 problem, but I wanted you to see that it kind of makes sense, right? You could do that, maybe. If not, if it didn't have those ugly fractions in it, I definitely think you could do it. You just have to remember to complete the square triangle. Okay, come back if you can stand the bad math jokes for the next section. Math is great.